Well, I'll be quick. I know there's a lot of people that have seen this before, but I noticed there's a lot of people that are, I think, are here for the first time and kind of curious. So we'll talk about sting operation. This is sting operation. Yes, this is what you do if you're such a fanatic about coming to Brew Robotics Club that you need to be here even when you live on the other coast. So it's a telepresence robot, also known as an iPad on a stick. But there's some interesting stuff. So there's some motors. John, somebody was asking me about these motors. Are these
those are just like seat moving motors. Like
so the seat motors from a car? That's what I thought. Yeah, yeah. And we can move sharp friend here so you can see that. So I'll just do a quick rundown on some of the hardware here. So there's a Raspberry Pi, which provides, eventually will give us a Wi-Fi interconnection and allow us to actually do proper remote teleoperation over the internet. This is a Pi board running MicroPython. Gosh, imagine that. And that's doing the hard real-time stuff. There's two motor controller chips from, I think these are the Pololu ones, driving the motors. There's another motor controller guy to drive this LiDAR from a Nito vacuum cleaner.
Those moving awfully slow. Those aren't realized.
And no, we have with auxiliary googly eyes stuck on the front just for effect. So it's kind of a work in progress, but it allows us to do radio control, teleop, and eventually teleop over the internet. Oh, one interesting thing that you might want to ask about is here we have a radio control receiver. And it's doing, if you're interested in understanding pulse position modulation decoding, there's a way that you can use a single GPIO pin to get all 8 radio control channels into your microcontroller. So one IO pin plus ground is all you need in order to get all 8 radio control channels in. It's a very simple piece of software to decode it. It's probably like 10 lines of code on an Arduino. I'll show you how to do it. I'll show you how to do it. So anyway, I just wanted to give a quick rundown. So if people have questions about it, you can ask me about it. And I will let the next person go since we haven't made a lot of progress on it in a couple of months. So
maintenance is progress.
Maintenance is progress. Exactly. It still runs. It ran last month and it still runs. So there you go.
One of my kids says the learning economy size of that.
So, yeah, the beach. Any questions before I turn it over? All right. So there we go.
Anyway, I'm not going to fire this up because it needs to be connected to the Wi-Fi, but I'll show you what I've got here. So this is really the Dexter platform, the GoPi Go 3, that we built a Let's Robot.tv telepresence robot that a woman named Jillian put together on her team. I'm working with another small educational robotic startup. So basically, she's got a Pi 3 with this GoPi Go 3 motor controller board on top of it. The original motors well, let me tell you what we're doing with it and why it ended up with this shape. What her software allows you to do is take the Pi, attach it to this little platform with the little caster and the 2 little yellow motor packet drives, and drive it around. We had it running with some AA batteries, rechargeables, and it would speak with a speech synthesizer and stream video reasonably low latency through Let's Robot.tv. And so you go to the website right now and there's like a bunch of people running robots in their house, and you can drive around, and the code's open source. You can download it and install it on a Raspberry Pi 3. She's got a webcam here and a little $15, $17 Adafruit speaker thing that's stereo, by the way. So we get stereo audio in and out. So anyway, this was running around our office. My goal was to kind of keep this running for, a couple of weeks. And people are like piling up the garbage pails by the front door and stuff. And every couple hours I got to pull the AA batteries out and spend the next half a day charging them and putting them back in again. So I added a little extra 5-volt, power pack to run the Pi, and it threw the weight off of this. And they were also getting this thing hung up on chair legs and stuck regularly. So I built these bumpers. So Roboterra, the company that I'm working with, actually we put together these sort of erector set Arduino kits that we're selling into education. And so I started using the erector set pieces to build a little bumper so this wouldn't get tangled up. And I had to build these little lifts here to help get it, over certain bumps in the floor so that, because this would get caught. And eventually I put a massive battery pack on this thing so that, I'd only have to charge this thing once a day. When I go home at night, I just put this on the charger, and the next morning I just run the whole day. So hopefully next time I can figure out the Wi-Fi and try and get this connected and show you. But the cool thing is they've got these interactive typing chat rooms, and there could be dozens of people in the room, and they're all pushing forward, backward, left, right, competing for control at times, and they're able to type in, and what they say comes out the speaker. They've got a login, so you can ban them if they're using anything inappropriate. But it's a very interesting environment because the robots are running around the floor, and they actually look up to the humans and call you like mom or dad. And it's interesting, the perspective, because you're running around at ankle height like a small pet. So
we had them do the TableBot challenge in June.
You did?
Socially controlled robot, and they didn't drive it off the cliff.
That's amazing.
Amazing.
Well, I would think it's like
it was there. It was
one
of the crowd.
It could have been done. Yeah.
To hose them,
Lemmings.
So it's very interesting. So yeah, we're just I thought I'd bring this in to show you guys. So what ended up happening is these motors. What's interesting is they've got encoders on them, and the Dexter GoPi Go 3 board was using feedback. So it would tell the motor, okay, turn a certain amount, so we can almost dead reckon. To be able to drive in a straight line on a turtlebot's kind of a big deal. So you either need an IMU or you need encoders on the wheels to try and make sure that when you push on both wheels, one's going to turn more than the other. And so if you don't have some way of keeping track of how much they turned, or if you've twisted your orientation as a robot, you're just going to end up going in circles when you're trying to go in a straight line. So these motors burned out, and they had encoders, and it was interesting because people were like pushing against the wall or trying to push doors open, and the motors, because of this feedback loop where they were trying to make sure their wheels turned a specific amount, well, the wheel got enough traction on the carpet or whatever that it would just sit there and push, and all of a sudden I'm smelling like this burning smell from this robot, and I'm going, what the hell? And there's the robot like wedged against the door, the motor's like at full torque, and as I picked it up, the melted heat glue that was over the connectors melted onto my hand, the hot glue from the glue gun, right? So it was hot enough to like melt the glue gun. So, fortunately Roboterra actually had motors with encoders, and I just managed to splice the cables together. I didn't even have to I was able to plug right in the connectors here on this end and managed to get encoder-based wheels that were compatible, that can handle a little bit more torque and current. So, anyway.
We're going to take a couple questions, and then we got to get on to our next.
Yep. Questions? No? All right.
Okay.
Is this the same? Do they still use this for the Let's Robot? Is it the same platform?
Yeah, this is still on the Let's Robot.
Okay.
So we're researching.
What's the URL?
Letsrobot.tv. LETSROBOT.tv. I want to get you down there to play with the laser cutter too, Chris.
Yes. What's its name on Let's Robot? What's its name on Let's Robot?
This one is called Cow. Cow, C-O-W. So, it runs around going moo all the time.
That's a good reason.